Welcome everyone to the How to Go Solar Plus Storage webinar. My name is Abigail Jager. I'm a program manager with Solar Oregon, and today we're going to be going through everything you need to know in order to get solar and or battery storage with confidence. So on the agenda today, we're going to start by going over how solar works. We'll see the components in a system, learn about the process called net metering that allows you to get credit for the energy you export to the grid. And we'll see how solar saves you money on your utility bills. Next, we'll take a look at how solar contractors assess your home. We'll see common issues with your site that can increase the cost of a solar installation or that can prevent you from being able to go solar altogether. We'll then take a tour through the exciting and popular topic of home energy storage and see how a battery can allow you to use power when the grid is down. After that, we'll learn about the incentives available for solar and battery storage, and we'll walk through several example budgets. We'll wrap up by talking about contractor selection and the installation process. The goal today is to get your questions answered, so we'll have an extended Q&A at the end of the webinar as well. Any and all questions about solar, battery storage, or even related technologies are welcome. Right now, I'm going to put some links in the chat. These are just some general resources that are useful to have, and we want to make sure you get what you need. And I'm going to go ahead and launch one of the first three polls. These are completely optional polls that just allow us to know a little bit about who is in the Zoom room with us today and allows us to have some information for when we're applying for grants. So as I said, I'm a program manager with Solar Oregon. Solar Oregon is a 501c3 nonprofit that has worked to encourage solar and storage adoption throughout Oregon since 1979. We do this by providing reliable and impartial consumer education like this workshop, working to build the clean energy community and performing outreach and some policy advocacy. We also facilitate solar tours, zero energy showcases, expert panel discussions on a range of topics related to solar, and Solarize campaigns, which are regionally focused short-term events that help you access solar discounts by going solar with your neighbors. You can learn more about us on our website at solaroregon.org, which is also shared in the chat. Thank you so much to those of you who participated in that first poll. I'm going to go ahead and launch the second poll now. This workshop series is supported by Energy Trust of Oregon. Energy Trust is an independent nonprofit established in 2002 that provides resources to help enable customers of investor-owned utilities in our state to use energy efficiently and gain access to renewable energy. They offer key incentives for solar installation and battery storage and coordinate a network of Solar Trade allies who are able to offer these incentives. We will talk more about Solar Trade allies later in the presentation. But for now, thank you so much to Energy Trust for your continued support. For more information, you can visit energytrust.org or check out the link in the chat. Again, thank you to those of you who were able to fill out that second poll. I'm going to go ahead and launch the last poll now. So, the slide seems to have disappeared, but as I said, we'll be having a Q&A at the end of the presentation. There should be a Q&A box at the bottom of your screen right below me. If at any point during the presentation you think of any questions you have, please feel free to put them in. You do not need to wait until the end of the presentation to put your questions into that Q&A box. You can put them in at any time. And now with that, I'm going to end this final poll and get started with the presentation, starting with talking about how solar works. This is a diagram of a typical home solar system. You can see the house in the middle of the diagram and then you can see the photovoltaic or PV panel over on the left. When sunlight strikes the solar panel, labeled here as a photovoltaic or PV panel, it produces a voltage of electricity. What the electricity it produces is a special type of electricity called DC electricity, which is different from the AC electricity used by the lights and appliances in your home. That's why we have another special device called an inverter or microinverter that converts the electricity produced by your panels into the AC electricity used in your home. So that sunlight hits the panel, generates electricity, but then it has to flow down to that inverter or microinverter to get converted into usable electricity for your home. From there, it then flows to your home electric panel where it is used to power your lights, charge your devices, charge an electric vehicle, and everything we use power for. If at any given point in time your solar panels are generating more power than your home is using, then any excess power flows out to the grid through your new bidirectional utility meter to be used by your friends and neighbors. And similarly, if at any time, such as at night, your solar panels are not producing as much electricity as your home needs, you're able to pull electricity from the grid to help power your home. This is called a grid-tied solar system, as you are still connected to the grid, and is different than an off-grid system where you would not have that grid connectivity. The bidirectional utility meter I mentioned is what allows what allows the power company to track how much power you are exporting and give you credit for that, and through a process called net metering. We'll be talking about that more in a little bit. As you can see, all in all, it's very simple and there's just a few components relate. And that's one of the things that makes solar so great for many people, is that's highly modular and can work in a variety of scenarios. We're going to be looking at some of the pieces of this system in more depth on the next slides. So now let's take a close look at the component that converts the DC electricity of the solar panels into the AC electricity for your home. There are two options available: inverters and microinverters. The white box in the image on the left is an inverter, sometimes called a string inverter, and it accepts all the electricity from all your solar panels and converts it all at once. This means if you have 10 solar panels, you would only have one inverter. The inverter is typically installed on the wall immediately next to your electric panel, aka your breaker box. However, if space is not available near the breaker box, it can also be installed outside. In this case, there may be extra costs due to longer conduit runs. The smaller black boxes pictured in the image on the right are microinverters. These are installed immediately beneath the solar panels, and each microinverter takes in the electricity from only one or two solar panels. That means if you have 10 solar panels, you can have up to 10 microinverters. Both inverters and microinverters are great options that are installed frequently in Oregon. Your contractor may suggest one over the other based on the specific needs of your system, but both are great options, and it's a great idea to ask your contractor why they are recommending one over the other. In order to be ready for your solar, your main breaker needs to be rated for at least 200 amps, meaning it can handle at least that much electricity in most cases. Larger homes may require even larger breaker boxes. Common signs you will need to replace your electric panel before installing solar include: your main breaker is rated for less than 200 amps. You plan to install solar battery storage and/or an EV charger now in the future. You plan to install more electric appliances such as a heat pump or heat pump water heater. You plan to install a pool or hot tub now or in the future. And if you're already experiencing issues with your current electric panel, like tripped breakers or flickering lights. Solar can be mounted either on your roof or on the ground. Roof-mounted systems account for the vast majority of solar installed on homes and businesses, especially in dense urban areas where ground space is not available. Ground-mounted systems can be a great option for families with more space. However, because they still need to be wired into your home's electrical panel, ground mounts installed far from home can increase the total cost of the system. This cost is partially due to the high price of copper in the wiring, as well as expenses related to burying the wire underground. As mentioned earlier, when your solar system is producing excess electricity, it gets exported to the grid, where it can be utilized by other utility customers. Net metering is the process that allows you to account for the energy you export so you can gain credit for it. Now let's illustrate how this works by walking through two examples. First, a typical sunny summer month, and then a typical cloudy winter month. The graph on the left shows us what's happening in a summer month. The orange bar shows how much electricity you've produced with your solar panels, and the blue bar shows how much you've used with all your lights, appliances, and outlets. Because you've produced more than you've consumed, this is a month you're exporting electricity. The green arrow shows the difference, which is your net metering credit earned. The graph on the right shows a typical winter month, when you're using a similar amount of electricity but producing less with your solar. The red arrow shows the amount of electricity you'll need to purchase from the grid. With net metering credits, the credits you earn during the sunny summer month offset the electricity you purchase in the cloudy winter months. While your net metering credits roll over from month to month, it's important to note that it does not roll over from year to year. The net metering year begins in April, and this allows you to build up credits during the sunny summer month and use them all winter long. Any excess credits you have at the end of your billing cycle in March, when the net metering year ends, are donated to the grid to low-income customers, and unfortunately, you will not get any payback for those credits. So now let's see what this actually looks like when it comes to your bill. Here's an example of what your monthly electric bill might look like when you are net metering with solar. This is an example from a PGE customer. So if you are a Pack Power customer, it might look a little bit different. But I'm going to still walk through some of these details. In the box on the left, you can see the period for which you're being billed, the reading on your bidirectional meter at the beginning of the month, and the reading at the end. Thanks to your new bidirectional meter, the electricity you import from the grid is recorded separately from that which you export. You can see the total amount of electricity coming into your home this month was negative 327 kilowatt hours. This means that you exported more than you pulled from the grid, and you now have gained 327 kilowatt hours of credit that you can use later. Because you are a net exporter this month, your billable kilowatt hours is 0. Excuse me. You may be surprised, however, to find that your bill is not 0. This is because your utility connections comes with a base charge. This is what all utility customers pay to maintain the grid. There are also taxes and fees that can increase your bill a few dollars. Compared with that average Oregon utility bill of about $100, this is still a great deal. This is an example of the savings you receive on your electricity bill each month for the useful lifetime of your solar system. And compared to the rest of the country, while the Pacific Northwest has cheap grid electricity due to our abundant and well-utilized hydroelectric dams, electricity prices still increase steadily, typically at a 2 to 6% rate per year. So as I said, those net metering credits build up during the sunny summer months, and then you use them up all winter, but they do not roll over from year to year. This means that the size of your system is very important. Solar is highly modular, and residential solar systems vary widely in size. System size is measured in a unit called kW, or kilowatts, and the average residential size in Oregon is 8 kilowatts. What determines your system size? By far, the biggest constraint is how much electricity you consume. This is because the goal of your solar system is to meet but not exceed your estimated annual consumption. Your contractor will ask you for past electrical bills to determine your future needs. If you are expecting to install appliances or make life changes that will significantly increase or decrease your expected consumption, make sure to let your contractor know. Examples include switching between gas and electric water heaters, purchasing an electric vehicle that you intend to charge at home, and having a child move in or out. Other factors that can limit your system size are available roof space, budget, or limitations placed by an HOA. Though on that last one, it's important to note that here in Oregon, HOAs can't tell you that you can't go solar. They can only place limitations on how you go solar. And if you're having some issues navigating your HOA with that, please feel free to reach out to us at info@solaroregon.org. Now, how can you know if your home is right for solar? Regardless of your location in the state, the orientation of your roof has a big impact on your solar access. This diagram shows a home and its orientation with respect to the cardinal directions. The arcs over the home show the path of the sun in the summer and the winter. Regardless of the season, the sun will always be in the southern sky. This means that south-facing roofs are ideal for solar. However, both west and east-facing roofs can work great. In cloudier parts of the state, roofs facing due east can be slightly less effective. This is because clouds tend to persist through the early morning, blocking some of that sunlight. The only roof planes that consistently don't get installed on are north, northwest, and northeast facing. Even if you have a perfectly south-facing roof, shade from objects like trees and buildings can prevent you from receiving enough solar resource. However, it can be hard to self-assess whether shading your roof receives will negatively impact you. Your solar contractor will be able to assess this for you with precision, either using a special measurement device or satellite-based software. One of the biggest factors that can affect whether you're able to go solar is your roof condition. Your roof will need to be replaced when it reaches the end of its lifetime, and when you do that, you'll need to pay a solar contractor to uninstall or reinstall your system. This service can cost up to $10,000, so it's very important to plan ahead. For this reason, we strongly recommend that you have at least 10 years of roof life left when you install solar. Different roof types have different lifetimes, metal roofs typically having a much longer lifespan than asphalt shingle. However, virtually all roof types can work well with solar. If you expect needing to re-roof in the next few years, you should wait until that time to install solar so that the roof life matches the life of the solar panels. In addition to what's on your roof, the shape of your roof can also make a difference. Solar systems can be split into several sections and span multiple roof planes. However, the ideal roof will allow for a single continuous installation on one roof plane. And just like what's on top of your roof and the structure of it, what's under and supporting your roof also matters. Newer homes tend to have trusses. These extra vertical and horizontal support beams meet even the strictest requirements for solar. Older homes tend to lack these extra support beams and might just have rafters extending from the eave to the crest of the roof. In this case, your home may still meet even stringent requirements, but based on the geometry of your attic, your contractor may need to hire an engineer to perform calculations for the permitting office before you're able to go solar. These extra costs, particularly for older homes in pre-1950s in Portland, it occur frequently in those types of homes. In rare cases, your home may not be able to meet local code requirements, even with reinforcements, and you may be prevented from going solar altogether if your attic is inaccessible or if there is not enough room for your contractor to perform reinforcement. So now that I've gone through all that, I'm going to begin talking about battery storage. It's important to know that your solar system by itself does not allow you to use solar during a power outage. To do this, you'll need a battery. The ability to use power when the grid is down is called energy resilience. Solar and battery storage are complementary technologies. Solar makes the battery more effective by recharging it, and your battery allows you to access your solar independently from the grid. Power outages vary in their causes, their frequency, and their duration. Frequent short outages are usually caused by either storms or squirrels in some areas. In some areas, slightly longer outages in the summer months can be caused by red flag weather conditions where there is high fire danger and the grid is off in order to lower the fire risk. In the Pacific Northwest, we also face a unique risk of a large earthquake, the Cascadia earthquake. When this event occurs, it's thought the power may be lost in the Willamette Valley for up to 6 weeks. On the coast or other rural parts of the state, power may not be restored for several months. It's important to know what type of outage you're expecting so that your contractor can design a system that will meet your needs. And it's also important to set your expectations. If you're preparing for an extended outage, you will likely need multiple batteries to store more energy, which will increase your upfront cost. When choosing a battery, there are many quality options. However, because of manufacturer certifications, contractors often specialize in a specific brand. To compare battery technologies, you may need to get quotes from multiple contractors, which we recommend. You can't mix and match battery brands, but some manufacturers offer different sized modules that can be combined. Battery capacities are measured in kWh or kilowatt hours. Most batteries range from 10 to 14 kWh. Smaller units are around 3 to 4 kilowatt hours, while larger ones can go up to 20 kilowatt hours. In Oregon, the average battery size is 13.5 kilowatt hours. For standard household electrical loads like lights and appliances, many batteries will perform well. If you're intending to use the battery to back up a load that requires a lot of instantaneous power, like a motor, your contractor will need to factor this into the system design. If you're interested in installing a battery, when you install it can affect both the system design and the price. Put generally, there are two options: installing solar and battery at the same time or adding a battery to an existing solar system. And why can the timing of battery installation affect the design of your solar system? Well, each system is designed in a custom way to best fit your needs, and the components are selected to match one another as closely as possible. This minimizes the cost to you and allows for immense flexibility of solar. However, this flexibility during the initial design phase means that adding new components afterwards, like a battery, may require more parts and labor than if you had incorporated them during the initial design. Because batteries and solar panels use DC power while homes use AC, your contractor can choose a single inverter if the system is designed together. Adding a battery later may require a second inverter. Late additions may also lead to inefficiencies like space constraints, longer conduit runs, and extra labor. For these reasons, installing a battery after the fact can cost up to $10,000 more than incorporating it in the initial system design. Batteries need a dedicated space, ideally near the electric panel, often in the garage. If space is tight, they can go on an exterior wall. Per code, batteries cannot be installed in crawl space, cupboards, or other confined areas. It is very important to set your expectations properly about what a battery can do and what it can't do. Even if you don't use much electricity, a single battery will almost always never back up your entire home for any meaningful period of time. However, what you can do is called a partial home backup. In this scenario, certain circuits in your home will receive power from the battery. The rest of your home will lose power during an outage. If you're able and willing to front the cost, multiple batteries can allow you to achieve a whole home backup. This process is prohibitively expensive for most customers, but is a simpler and more efficient process overall. When you get a partial backup, the way you divide your home into sections that are backed up and sections that are not is based on the breakers in your electric panel. When you've selected which circuits you would like to receive battery power, your contractor will remove those breakers and place them in a newly installed essential loads panel. The second electric panel will be wired to the battery. There are also newer technologies like smart breakers or smart electric panels that can provide more customization and flexibility. If you have an older home, you might need to upgrade your electric panel anyway before you go solar. So it's a great time to talk to your contractor if you're already wanting to get a battery as well. The battery system sizing process will entail a detailed conversation with your contractor, balancing your desired functionality with your budget. Great way to think of this process is a trade-off between two questions. What needs power and for how long? Items most frequently chosen to back up include a refrigerator to keep food from spoiling, lights in common areas, and a couple of outlets to be able to charge a laptop or cell phone. So now that I've gone through all that, probably thinking that this seems very expensive and wondering how much it's going to cost you. So I'm going to now walk through some of the available incentives and financing options. The biggest incentive currently on offer to everyone in the state are Energy Trust incentives. Your Energy Trust incentives depends on the size of your system and your electric utility. Energy Trust standard and solar incentive is a flat $2,500 for both customers of PGE and Pacific Power. This is an incentive you receive immediately and which your solar trade ally applies for on your behalf. There is also a battery storage incentive that is $400 per kilowatt hour up to $5,000 for PGE customers and $320 per kilowatt hour up to $4,000 for Pacific Power customers. You can receive this incentive whether you install solar and storage at the same time or separately. Importantly, in order to receive this incentive, you must have your system installed by an Energy Trust Trade Ally contractor. They are the only contractors that are approved to offer you Energy Trust incentives, as they are familiar with all Energy Trust design and installation requirements and have already been approved to offer these incentives. If your utility is not PGE or Pacific Power, you will unfortunately not qualify for Energy Trust of Oregon incentives, but your utility provider might have other incentives available, so it's always a good idea to reach out to them and check. The availability of incentives varies and are subject to funding availability and current policies. You can check with your provider to see what incentives they offer. In addition to the standard incentive, Energy Trust also offers an income qualified incentive. Energy Trust of Oregon Solar Within Reach incentive is a $1 per watt incentive and allows PGE and Pacific Power customers to reduce their installation costs. For example, a household of 4 qualifies for Solar Within Reach if their total income is less than $128,564. You can find the cutoff for all household sizes on the Energy Trust website, which is linked in the chat, or you can scan the QR code currently on your screen. This incentive works very similarly to the standard solar incentive, where it is a $1 per watt incentive with a flat rate for solar and a amount per kilowatt hour installed for storage. Because solar and battery storage entail a large upfront cost, many homeowners utilize financing. Some homeowners obtain a loan through a bank for which they have an existing relationship, but some banks do not provide loan products specifically tailored to solar. Your contractor may partner with a credit union or third-party broker that offers a package that is geared towards solar. As with any major financial decision, make sure you carefully assess your financing options. Energy Trust of Oregon recently launched Smart E-Loans in partnership with Solar Trade Allies Inclusive Prosperity Capital, a 501c3 clean energy financing platform. ETO Smart E-Loans can be used to install solar plus battery storage, an electric vehicle charger, and enabling upgrades and/or repairs, all paired with a qualifying solar system. These are some of the benefits of the Smart E-Loans. Transparency of a clearly stated interest rate without any other hidden fees. No fee or prepayment deadline penalties. It is an unsecured loan with no need for collateral. Low FICO credit scores as low as 580 are accepted. Flexible terms of 5, 7, 10, 12, and up to 20 years. Rates as low as 6.99%. And an easy application process. Unfortunately, the Smart E-Loans are limited to PGE and Pacific Power customers within Energy Trust of Oregon service areas. If your local bank or credit union may be one of the suppliers for the Smart E-Loan, and you can always reach out to them and see if they have another program if they are not. For more information, a list of possible lenders, you can find it either through the Energy Trust of Oregon link in the chat or by scanning the QR code currently on the screen. Before we look at some example budgets for solar and storage, we should recap the reasons why both solar and battery storage costs vary so widely. The cost of solar depends on the size of the system, if you need to re-roof, if you need to perform any structural analysis or structural reinforcement. And the cost of battery storage can be dependent on if you're installing at the same time as solar versus afterwards, how far you're installing your home storage system from the electric panel, if you are creating an essential loads panel, how many batteries you're installing. In addition, the availability of incentives can affect costs for both solar and storage. For these reasons and more, it is impossible to quote the price of solar without having information about your site. Please keep this in mind while I walk through the example budgets on the next slide. So here we can see the cost of both a 8 kilowatt solar system and a combined 8 kilowatt solar with a 13.5 kilowatt hour storage system. The cost of the straight solar system being $32,000 and the price of the solar plus storage system being $52,000. From there, the customer receives the Energy Trust of Oregon incentives to the maximum amount, making the total out-of-pocket cost to the customer for a 8 kilowatt solar system $29,500. And for a solar plus storage system, $44,500. There can be other incentives you may be able to access that can help you save additional money. And typically there can also be some increased costs if you're adding storage later. So now with all this information, now that you're ready and excited about solar, how can you get started? As mentioned, besides offering incentives for solar, Energy Trust of Oregon has a certification program for contractors to help ensure a high quality workmanship. Energy Trust Trade Ally contractors are rigorously vetted, highly rated, and are the only contractors who can offer you the Energy Trust of Oregon solar plus storage incentives. We highly recommend working with a Trade Ally contractor and getting at least 3 quotes to compare if you're able. When you're ready to get quotes from the contractors, there's an extremely convenient and easy tool on the Energy Trust websites that you can use to request free estimates from up to 3 highly rated contractors in your area. The online form takes only 3 to 5 minutes to complete and is a great way to make sure you're getting connected with solar Trade Ally contractors that can best serve your solar and storage needs. You can scan the QR code on the screen, or you can check out the link in the chat. Once you've selected your contractor, received quotes, and signed your contract, here's what you can expect regarding the installation process. Your contractor will handle all permitting, applying for the Energy Trust state incentives on your behalf, and designing your system. It is important to remember that they will need your signature on some of these documents, so the more organized you are, the smoother the process will be. Although system design can be quick, some jurisdictions have been experiencing permitting delays. Some counties have longer permitting times than others. For example, Multnomah County can often experience longer delays. However, once it's time to break down, installation is very quick. Most residential systems are installed within 1 or 4 days, making it a relatively painless process. Installation for solar is usually pretty quick, but it can take more time if you have a complex system design or if you're adding batteries. After the system is installed, your contractor will manage your permit inspections, coordinate the installation of your new bidirectional meter, and schedule your interconnection with the utility. This can take 2 to 3 weeks. After you've been interconnected, your system will be producing clean and renewable power from the sunlight falling on your property. All in all, it's pretty simple, and I hope that some of you are now feeling inspired to get started. But if you have any other questions, that's what this time is for. And I know there's already one question in the Q&A box. Please feel free to put any other questions into that Q&A box, and I'm going to get started with them. So the first question we have is if I would recommend a smart panel. So whether or not I recommend a smart panel really depends on the needs of what you're looking to do. Smart panels can be really useful. I know people who enjoy the flexibility they have and how they move circuits, and having the ability to set between 3 different levels of must have, nice to have, and not mandatory. And I also know some people who use it in a more creative way, such as automatically shutting off their kids' video games when it's bedtime. However, with that being said, it is newer technology and therefore more expensive, and also can be prone to have more bugs and issues. So it depends on where you want to be. If you want to be on the cutting edge, a smart electric panel can be a really great option. But if you don't care about having that flexibility, going for that partial home backup can also be just as good. Please put any other questions you have into that Q&A box. I'm here to get your questions answered. And while people are thinking of questions, I'm going to go ahead and launch the last poll. The next question I got is if there are any changes planned to net metering programs in Oregon. As far as I am aware and have heard, there are not. However, I do not have a crystal ball, and we cannot guarantee that the programs that are currently in practice will be sticking around for a while. A couple of years ago, PGE did make some noise about wanting to sunset net metering and move to a net billing program, more similar to what is currently happening in California. However, that was successfully halted by the Save Oregon Solar Coalition, and I have not heard any noise about that recently. If you want to check out more about that, searching the Save Oregon Solar Coalition would be a great place to start. And someone else asked to see the price slide again, and yes, absolutely. Here you go. And someone asked if the slides will be available. The PDF of the slides will not be made available, but a recording will be sent out to you by the end of this week. I'm going to end that poll and thank you everyone for being here tonight. I'm here to answer your questions, so I'm going to stay on for one more minute to see if any other questions come in. But otherwise, thank you so much for being here, and I hope you have a great rest of your evening.